We're at All 3D Labs up in Wetherby. Now, they've made a huge investment. They're a brand new company. They're 3D printing bureau. Lee, you're from Matsuura. Why would they use you guys, HP and Dimension?
Well, Matsuura, as you know, has been a long time in the marketplace, well known for their machinery, but also recently, well, I say recently, over the last few years, have developed a relationship reselling for the HP and the Dimension brands. Again, high quality bits of equipment. It's why Mark has looked at that as his investment that he wants to go forward with.
Yeah, there's a lot of products out there, and it's a big commitment, so he's chosen you guys.
Absolutely, yeah. It's all about the quality, but again, as mentioned, it's about the service as well.
Absolutely. What I want to do, though, is look at the actual process, because there's a number of different processes here, which is all really interesting.
Yeah.
Because there's different styles of 3D printing. So what is it, and this is the first stage?
This is the first stage. This is classed as this is the build unit. Normally what we do is they have two build units that's supplied, so you'd have one in the post-process station, one in the printer. We'll go through that a little bit more. But this is the first process. Now this build unit is what goes initially into the post-process station, and that's filled with powder. Nylon based. In what Mark's using, he's using a PA12.
There's different styles of...
There is different styles, yeah. You've got PA11, PA12, TPU and PP. PA12 is what Mark's chosen for generally the work that he's doing.
Okay, so fill it up, then let's go and look at the next stage of the process.
Okay.
Lee, next stage of the process.
Yeah, this is the HP 5200 printer. This is, yes, as you say, it's the next stage in the process. So once you've had it in the post-processing station, the build unit, and you've filled it full of the powder, it's an easy process, nice and clean. All the powder's contained within the build unit. You take the build unit from the post-processing station and you bring it to here, and it just basically slides in.
Nice and simple.
Nice and simple.
What about the working envelope?
The working envelope is 380 by 284 by 318 in height.
Can we have a quick look inside? Yeah,
of course, yeah.
So essentially everything's being printed in there. I mean, that's...
Yeah,
wow.
that's correct, yeah. So, what you can see here is the powder that lays down layer by layer. That's the PA12 powder as mentioned earlier, yeah.
And what's the benefit of this? Because there's different types of 3D printing. What's the benefit of this style?
It's a rigid material. There's no supports. It's self-supporting because the parts actually lie within the bed of the powder once it's been printed. So a big plus there is not having any support removal to do afterwards. As well as that, it's isotropic. So some forms of printing can be quite weak in the Z because of the process it's done. This keeps the rigidity right through the process. A uniform sort of type of build is what you're gaining here from this sort of binder jet technology. Okay,
and how is it? I mean, I've got a design in my brain, right? What do? I send a picture through to Mark at All 3D Lab?
I mean, it's a really straightforward, easy process. You send the STL model to someone like Mark, and they will put that into some of the software that I have. Now, the software can be really intelligent, so it could be a number of parts that you could get within that. So it doesn't have to be one part within the build. You could have a series of parts. And the software is very intelligent in form of basically nest the parts in order. And it will tell you how many parts you can fundamentally get out of that build as well.
So depending on the size, I could have 500 really small parts, all different as well.
Yeah, absolutely. Yeah, if you've got an assembly of parts, it's a perfect way to look at producing those all in one go, really.
Okay, so I've loaded up my build unit.
The build unit, that's right. Yeah.
Press a button. It's printing away.
Yeah.
Application specific for how long it's going to take.
Yeah, I mean, you can do a full build, you can do half builds. You don't necessarily have to do. It's about setting, but it's a really easy system. It's just like having a normal HP printer at home. It's a very intuitive system, so you don't have to be sort of somewhat expert, let's put it that way, to use it. If you follow the step-by-step process on here, you get it printing very, very quickly. Nice and simple. So I've printed it all off, back to the machine we were at previously. That's correct. Once it's done, probably around, say, 9 hours for a full build, 9 to 10 hours, you would then remove it. So again, like this, taking the build unit out, back over to the post-processing
Back we go then. Back at the post-processing station.
That's correct.
Happens?
So now what you would do is put the build unit back in here. Now it does need a process to cool that because it gets up to a temperature about 160 degrees while it's printing. So that powder is extremely hot when it comes out. So what you would do is you bring that build unit back into here and you'd allow that to cool. Now the cooling process, naturally cooling process, is about the same time as it takes to print. So hence the reason normally our customers will have at least 2 build units. So you've got one in print while one is sort of cooling. Now once it's cooled, that's when you can start unpacking the build. So the components taking powder. Now you've got this sort of vacuum here, which will remove the majority of the powder out.
So when
of
you
that,
say unpacking, you're just hoovering essentially.
yeah, you're just hoovering it. Yeah. In simple terms, yeah, you're hoovering that powder out. Then, as you're hoovering the powder out, you'll remove the components that are self-supported inside there, and you'll just get off most of the remnant powder off those parts, put them to the side. So it's a very easy process that, and it's all vacuumed at the back as well. So it's good. You don't need to wear, particularly where as a sport. Probably want to wear gloves, something along those lines.
Health and safety.
For health and safety, but it's because of these screens and that, it's vacuumed a lot of the powder back as well.
And then you've got your product.
Yeah.
You've got to finish the process. There's a number of different options. Let's go and have a look at the first one.
Okay.
I've got my final printed part, but essentially the final clean here.
That's correct, yeah. What you'll get most of the powder off at the post-process station, but you then need to clean the part off a bit more finer. So you've got this PowerShot C from Dimension here. There's 2 processes. There's a manual way to blast the parts, or there's an automated way. It's a bit like a washing machine drum. So you place your parts inside there, it'll revolve, and it'll find the fine medium at the part to clean off all of the remnant powder on that part, as you can see down here. You can see, yeah, that's sort of typically how fine that is. And then ultimately that is then the finished product after it's been cleaned.
Okay, that's a finished product, but I have other options as well. So it seems opportune we go and see the PowerShot S.
That's correct, yeah.
PowerShot S, and you can actually see the manual option here.
Yeah, that's correct, yeah. The door will come down and allow you to get your hands in to do a manual process as well. But
for the larger parts?
For larger parts, yeah, that wouldn't fit inside the drum. It's a very similar process to the C. A drum revolves, but it's got a bit of a larger, sort of a 1/2 mil sort of plastic bead that you can see there. That's blasted at the part to give it a sort of polished finish. You can see here.
So a matte finish, but also you printed a revolving wheel in there as well.
That's correct. That's the beauty about designing for additive and the way the HP works, is that you can do things within the powder because it's all self-supported. As long as that powder can come out at the end of it, you can put parts, working functional parts together. We're not talking prototyping, we're talking end user parts as well here.
Okay, great examples there, but we've got one final option. Let's go and have a look at that. Lee, if I want that different surface finish, this is a completely different process. What's going on here?
Yeah, this is a vapor fusing technology, so it's sort of chemically smoothing. So it's like a benzyl alcohol basically to give a highly sort of polished look of the part there. Very similar to sort of more injection mold-like qualities. You can't tell that would be 3D printing, the difference between the two at that point. So this process gives the overall a really nice shine finish there, but it also completely watertights the part as well. So for industries maybe like the marine, where things are being submerged in water, it's an ideal sort of solution for those to finish off those 3D printed parts.